Good evening. Welcome to Space Oddities. How are you all today? Thank you for being here on this lovely Tuesday evening. It is here in Spain. Hope it's okay where you are. Thank you for being here. And who we got? Nobody else. Ian, thank you very much for the donation, sir. And keep them coming. That's all I can say. Thank you so much. Much appreciated.
Yeah, definitely.
So this evening, what have we got for you this evening? Well, what we've got for you this evening, we're going to carry on with our countdown to Artemis, the Artemis mission, which has been delayed again, but we'll talk about that when we get to the news. We're going to be looking tonight at the broader picture with Artemis, the goal of which, of course, is to return humans to the lunar surface, which is currently scheduled for around 2028. If it doesn't slip, but we're going to take a larger view. We're going to look at the whole issue tonight of what does it take to actually live and work on the moon? What are the dangers and the hazards involved in living and working on the moon? And we're going to be having a look at the whole question also of when humans return to the moon in a couple of years, where are we going to land and why? So we've got that as well.
I hope it's near a fast food place because they're going to be hungry after 3 days.
So we're going to be looking at that. We've also got this evening the first in our heat that Dave's doing, our sort of Messier knockout competition, where we're going to ask you to nominate your favorite Messier objects from the choices that Dave is going to give you. The idea of this is to come up with what's everybody's favorite Messier object for whatever reason. So I'll let Dave tell you a bit more about that later. We hope you've had a fantastic week. It's been a glorious week here in Spain. T-shirt weather, hot sunshine, really lovely. So if you're suffering still in the UK with rain and low temperatures, and if you're in the US on the East Coast with the terrible blizzards that they've had there, sorry about that. Hope you're all okay. And there we are. Don't forget, if you would like to support Space Oddities, you can do so in the time-honored fashion. First of all, you can buy us a coffee because astronomers' lives matter, and we need our caffeine levels topped up from time to time. So if you either scan the QR code here or click the link that's just appeared in the chat, that will take you to the Buy Me a Coffee page where you can buy some coffee, and much appreciated it is too. You can also make a donation directly to Space Oddities by clicking the Super Chat icon. That's the one with the $sign under the chat window, and that will allow you to make a donation directly. Plus, of course, to have your very own summer apparel bearing the Space Oddities design. T-shirts available for £20, including UK postage and packing. Again, you can scan the QR code or click the link in the chat. And because winter lower temperatures are going to be around for just a little bit later, you might want to buy yourself a Space Oddities hoodie. These start at £40, including UK postage and packing. And if you're outside the UK, please add £10 to the total value of your order. So there we are. We've got a few things in the news this week. So I think we'll just crack straight on with tonight's news. Not a huge amount of news this week, but what we're going to give you is this. Here's the news for the 24th of February. And let me just get to where I need to go, which is there. Okay, so first of all, on the news tonight, we're very sad to hear of the death of Carl Grillmeyer. Carl Grillmeyer was an experienced astronomer, award-winning astronomer. His main claim to fame that he and his team discovered the first hints of water in the atmosphere of an exoplanet. And he has had a long and glorious career as an astronomer. Unfortunately, Carl was shot dead on the doorstep of his home near Los Angeles a few days ago by an assailant who was later arrested, or allegedly arrested. They have arrested a 59-year-old man in connection with the murder. There doesn't appear to be a motive that's discernible at the moment, but the astronomical community is really shocked. You know, for whatever reason, this assailant decided to take the life of Carl Brillman. Guys, is somebody playing around with their microphone or something? There's an awful lot of sound coming from somewhere.
No, not me.
So then, anyway, sorry to have to report this. So rest in peace, Carl Brillman, and no doubt in time we'll learn the reasons behind this awful crime. So there you are. The SLS, which will launch the Orion capsule to the moon for astronauts to take it on a circumlunar flight around the moon. It's been delayed again, I'm afraid. And you may remember that during the first dress rehearsal a couple of weeks ago, the SLS developed problems. It had a hydrogen leak, had a faulty seal, had a faulty valve. NASA fixed all these without the rocket having to move back to the VAB, the Vertical Assembly Building. Last week, they tried another wet dress rehearsal, which went off perfectly. But after the dress rehearsal, they discovered that there was some sort of impediment to the flow of helium to the upper stage of the vehicle. And this is something that cannot be fixed in situ. So they're going to have to roll it back to the VAB sometime within the next few days, possibly. What this means is that Artemis 2 will now not launch to the moon earlier than April. So sorry to have to report that. Bit all doom and gloom tonight, I'm afraid. However, on a lighter note, how does the Perseverance rover on Mars know where it is? Does anybody want to answer that question? Team, anybody know how the Perseverance rover knows where it is?
Knows where it is.
Sense.
Sense.
No idea.
No.
Good question.
They send some instructions from the ground to tell it where to go.
Does it sight the horizon, objects on the horizon?
No.
It's not got a sextant now.
All right, I'll tell you. It basically has to phone home. It has to contact the Earth so that it can be told where it is. But not anymore, because it's gained a groundbreaking new capability that lets it determine its own position on the red planet without waiting for instructions from Earth. Effectively, they've given it a sort of Mars GPS ability. Historically, the rover had to rely on orbital imagery, onboard sensors, and guidance from Earth-based mission teams to estimate its location, a process that could accumulate errors over long drives due to wheel slip and terrain uncertainty. The new system is called MGL, which stands for Mars Global Localization, and it enables Perseverance to match panoramic images taken by its cameras with detailed orbital terrain maps stored on board. And an onboard algorithm performs this comparison in about 2 minutes and can pinpoint the rover's position to within about 25 centimeters.
Wow.
And this precise localization reduces the need for frequent stops to await confirmation from Earth and allows the rover to traverse further and more autonomously each Martian day. Now, this upgrade builds on ongoing efforts to enhance the rover's autonomy and comes as teams increasingly deploy artificial intelligence and advanced navigation tools to improve the rover's operational efficiency. So well done, NASA. That's wonderful. So
That's very cool.
You know, Andy, some years ago, when I was working for both NASA and NOAA, and NOAA had the SARSAT, Search and Rescue Satellite program.
Yeah.
Where they, if you have an airplane or a boat and you're in trouble, you have a little transponder, and and it communicated originally with analog signals from various satellites going overhead, and it would produce an error ellipse that would get better and better the more satellites it communicated. Sure. Seems to me that the rover, we have orbital assets around Mars, right?
Yeah, absolutely.
A couple, though, right? Not a
great deal. We've got
well, India has one.
Yeah, Mars Express from ESA.
Right. ESA has one. Don't mean to leave ESA out, our good friends. So-
the MRO.
Right.
Mhm.
And a couple, at least a couple NASA. Right.
Yeah.
Anyhow, that's my proposal.
But I'm sure ESA would let you use Mars Express if NASA really wanted to. I don't think that'd be a problem. So
It's all Doppler.
he said, speaking for the whole of the European Space.
That's right, Andy. What power?
Yeah. All the power goes to me head sometimes. It really does. Okay, so anyway, this is great news. It means the rover doesn't have to keep stopping to work out where it is, basically, and await data from Earth to tell it. So this is good news. Okay, this is an interesting one. Has anybody heard of a thing called a failed supernova? No.
No.
Well,
Like,
we know the story.
Class or I don't know what.
Yeah.
Well, isn't that a failed star?
No. A failed supernova is when what happens is we know the story that massive stars go supernova and collapse into black holes if they're massive enough. Yeah. But sometimes they don't explode and collapse spontaneously into a black hole without an explosion. And astronomers have found they've seen one or two suspected examples before, but this one seems pretty clear cut. And this is in the Andromeda galaxy, and it's got the designation M31, of course, for Andromeda. 2014 DS1. It was actually first noticed in 2014 by the Neowise telescope because it had a strange, unusual increase in mid-infrared brightness. Over the following years, it faded and ultimately disappeared from optical and near-infrared observations altogether. Now, this suggests that the star's core collapsed under its own gravity without producing the powerful shock needed to drive a classic supernova, leaving behind a black hole. And scientists tracked its gradual decline using archival data spanning nearly a decade and confirmed definitively its absence by 2023. Unlike typical supernovae that light up galaxies for weeks, a direct collapse emits little visible light. And this makes them, of course, very difficult to detect. And it does support the idea that these failed supernovae are real pathways for black hole formation. It also might explain why we see fewer supernovae than are expected from stellar evolution models, because some of them are collapsing into black holes without going bang. So this has been added to the catalogue of these objects. But, it's yet another part of stellar evolution that we don't really understand, because these stars obviously have enough mass to form black holes. So why don't they explode as supernovae? It's a bit of a conundrum, that one. So there we are. Okay, lastly today, the aurora of February the 16th, I think it was. This is just a lovely nighttime image of the aurora between Canada and Iceland. And this beautiful curve of this glowing aurora. And it was taken by the Suomi NPP satellite, which is a joint mission between NASA and NOAA. And you're looking down at the Denmark Strait and across parts of Canada. This was a minor geomagnetic storm. It was only a G1. Of course, G5 is the most severe. So it just goes to show that even weak electromagnetic, geomagnetic storms can produce these absolutely stunning aurorae. So I just thought I'd show that because I thought that was an absolute beautiful image. So there we are. So that's the news for today. By the way, there won't be any Einstein of the Week this week, unfortunately, because I haven't found anything that was worth including. A couple of leaders, but no raucous belly laughter, I'm afraid. So we'll get back to that next week. I'm pretty sure. By the way, it's very remiss of me. I didn't say hello to the guys tonight. So hello, Roger. How are you? Yeah,
I'm fine.
Right. Okay. Thank you. Dave, you okay?
Good. Thanks.
We have delighted to welcome to Space Oddities the famous astronaut Bruce McCandless, or Luke Skywalker, as he is probably better known. And
Bruce.
good day, Bruce. So anyway, Tom McCrory, welcome back. So
Thank you.
well.
I'm good.
Well, that's a matter of opinion, but how are you?
Well, that's true. That's true.
Yeah.
I'm just hanging around.
Yeah, fine. Good. You're looking well. Lou from the States as well.
Life is great until about 8 o'clock tonight, I guess.
Yes. When do you finish your teaching?
Well, I have two classes. One from my time is 5:15 to 6:30, and then another one from 6:45 to 9.
Right. Okay. And when does term end?
Not soon enough.
No.
I hope you're listening to this.
Oh, boy.
I think it's early May.
That's right.
Oh, right. Okay. Right. All right then. And last but definitely least, Michael.
Okay, let's move on.
Moving on. Yeah. By the way, viewers, just to give you plenty of advance warning, not that it makes any difference to you, I'm sure, and why should you care? On Tuesday, April the 7th, I'm not going to be here because I'm going to Dublin to see some friends. So Daz will be hosting the show on Tuesday, April the 7th, just to give you advance warning in case you don't want to watch. So there we are. Okay, let's move on. So we're going to start looking at a lot of stuff to do with the moon, because we're carrying on our countdown to Artemis. And we thought we'd just step back from Artemis 2, which, as you know, is a circumlunar mission to send humans around the moon. It'll be the furthest that humans have ever been away from the Earth. So it'll be quite an historic mission just for that reason. But we're also looking forward to Artemis 3, the landing of humans on the moon, as I said earlier, in around 2028. So we thought we'd have a look at some of the issues involving that tonight. Now, humans will be landing in around 2028. We must put a big asterisk against that to say, times and dates may change. But where are they going to land? Well, the idea is to land at the south pole of the moon. So the question is, why the South Pole at the moon? It's more difficult to get to. The terrain is very rugged at the South Pole. It's not an easy place to land at all. So why go to the South Pole of the moon? And it's all to do with water. And what we're going to do now, we're going to have a look at a video which we published as part of our Moon Week last week, which is the story of water on the moon. So this is about 8 minutes long. So sit back and enjoy the story of water on the moon.
How can the moon have water? It's dry, it's dusty, it does not have weather, it has only the most tenuous of atmospheres. It's blazingly hot, it's numbingly cold. No clouds ever form above the moon, no rivers flow, no seas lap gently at lunar shores. 17th century astronomers gave the prominent dark areas on the moon the names of seas, like Mare Imbrium, the Sea of Rain. But they are not seas, they are plains of ancient lava, billions of years old. No soft spring rain will ever fall on Mare Imbrium. There's an ocean on the moon too, Oceanus Procellarum, the Sea of Storms. But no dark storm clouds will ever gather above it. So how could there ever be water on our beautiful natural satellite? One of the earliest proponents of the idea that there might be water on the moon was Harold Urey, a Nobel Prize winning chemist who who speculated in the 1950s and 1960s about the possibility of volatile compounds, including water ice, being trapped in cold regions of the moon. However, the concept became more concrete in 1961 when Kenneth Watson, Bruce Murray and Harrison Brown published a paper in the Journal of Geophysical Research suggesting that water molecules from cometary impacts or outgassing could migrate to and become trapped in permanently shadowed regions at the lunar poles. Between 1969 and 1972, the Apollo astronauts returned nearly 600 pounds of rock and soil from the moon. The samples underwent intense scrutiny from scientists around the world, a study which, nearly 60 years later, still progresses today. But no water was found in the lunar samples, confirming what scientists thought they knew, that the moon is completely dry. But then in 1976, the Soviet Luna 24 mission brought back soil samples with traces of hydroxyl, but this was largely overlooked. Hydroxyl, or OH to give it its chemical formula, is a molecule consisting of one oxygen atom and one hydrogen atom. It is not the same as water, but it is closely related. Hydroxyl can form when water molecules break apart or interact with minerals. In the context of the moon, it likely forms through interactions between the solar wind and oxygen in lunar minerals. It's a key indicator of water-related chemistry on the moon, even if it is not in liquid form. In 1994, NASA's Clementine mission detected reflections at the lunar poles, suggesting the possibility of ice deposits. Then, in 1998, NASA's Lunar Prospector found hydrogen signatures near the poles, interpreted as potential water ice. However, the images returned from both spacecraft were of such low resolution that the discovery of water could not be confirmed. This picture is a later image of the moon's south pole by NASA's Lunar Reconnaissance Orbiter, the water marked in blue. But then, in 2008, reanalysis of Apollo samples by Brown University scientists found both hydroxyl and water molecules. It seemed that initial analysis of the Apollo moon rocks had overlooked them due to the inadequate analytic technology of the time. Then, in 2009, India launched their Chandrayaan-1 spacecraft to the moon. Mapping the moon's surface with an X-ray spectrometer, the spacecraft created maps of mineral deposits. But it also released a small impactor, which, striking the moon's surface, also detected both hydroxyl and water molecules. NASA's LCROSS mission, launched in 2009, aimed to confirm the presence of water ice in permanently shadowed lunar craters. The mission targeted the Cabeus crater near the moon's south pole, where previous data suggested potential ice deposits. LCROSS deliberately crashed its Centaur rocket stage into the crater at high speed, creating a debris plume. The LCROSS spacecraft, following closely behind, analysed the ejector before it too impacted the surface. The debris plume was also analysed by NASA's Lunar Reconnaissance Orbiter, or LRO. Instruments detected water ice along with other volatiles, confirming that significant amounts of frozen water exist in these shadowed regions. This discovery was a major milestone, strengthening the case for future lunar exploration and resource utilisation, including human missions and potential in situ resource use. LCROSS provided concrete evidence that the moon holds accessible water, which could be critical for sustaining long-term lunar bases. There may be more than 1 billion tons of water ice locked up in the permanently dark craters at the moon's poles, where the temperature is a constant minus 230 degrees Celsius. So where did it all come from? Water-rich comets and asteroids bombarded the Moon in its early history, particularly in a period about 3.5 billion years ago known as the Late Heavy Bombardment, depositing ice that became trapped in permanently shadowed craters. It may also have come from hydrogen in the Sun's solar wind reacting with oxygen in lunar minerals to form hydroxyl and small amounts of water. There were also ancient lunar volcanic eruptions which released water vapour, some of which could have migrated to the poles and become trapped in cold regions. And the Moon is constantly being bombarded with small meteoroids containing hydrated minerals, delivering water molecules to the Moon over time. That water ice can be used by future human bases on the Moon. It could be used to extract the oxygen from the ice for breathing, further processed to produce rocket fuel, be used for radiation shielding, agriculture, hydroponics, thermal regulation, industry and many other applications. All we need to do is to find the ice and figure out an extraction and transportation system, but there is no doubt that the ice is there in large amounts. In 2023, India's Chandrayaan-3 spacecraft landed at the south pole of the Moon to search for water, but only detected hydrogen and oxygen separately, not as H2O. The US and Russia have also launched spacecraft to find the water, but so far their missions have failed. However, the US, Russia, China, India and Japan are all sending missions to the lunar south pole to search for the water over the next couple of years, so it's likely that at least one of those countries will find the water and eventually construct a base at the south pole of the Moon. It's taken 70 years since the first suggestions that there might be water on the Moon, but at last it looks as though we may find it and use it for the advancement of human lunar exploration. And there you have the story of water on the Moon. Thank you for watching, and I hope you'll watch the other videos in the Space Oddities.
On the Moon, hang on, there we are. That's better. I had a problem with my mic there. Sorry about that. Yes, so that's the story of water on the Moon. We know that the ice is definitely there, and it just needs a way of extracting it. And because of that, the south pole of the Moon is the obvious place to land, because it can be used for all the things that I mentioned in that video. Now, the lunar south pole is in darkness for a lot of the time. The sunlight never reaches the bottoms of a lot of the deep craters there. And just to give you an idea of what it's like, especially with regard to the sun and the Earth at the lunar south pole, got a very short, wonderful NASA animation which will show you exactly how the sun and the Moon and the Earth all interact at the lunar south pole.
I'm Ernie Wright. I work in the Scientific Visualization Studio at NASA's Goddard Space Flight Center. We're looking at a computer model of the view at the south pole of the Moon. This is like a time lapse to show the motion of the sun and the Earth and how the shadows change over time. Things don't rise and set in the usual way here. The sun travels around the horizon, never getting more than 1.5 degrees above or below it, so there are always these long shadows. And from here, the Earth appears to be upside down and rotating backwards, but that's just because of our point of view. The Earth doesn't move much in the Moon's sky. It's always in roughly the same place, just sort of bobbing around. That's true everywhere on the near side of the Moon. It's a consequence of the Moon always pointing the same face toward Earth. It takes about a month for the sun to make a complete circuit around the horizon, and every so often, it'll pass behind the Earth, creating an eclipse. I've slowed down time here a little so that it's easier to see. On Earth, that would be a total lunar eclipse, the Moon passing through the shadow cast by the Earth. But if you're standing on the Moon, it's an eclipse of the sun. The terrain at the South Pole is especially rugged. The rim of Shackleton craters in the foreground here, and the mountain off on the horizon, unofficially known as Mons Malapert, it's about 85 miles away. Shackleton crater is about 13 miles wide. Not quite as wide as the Grand Canyon, but it's twice as deep. sunlight never reaches the crater floor, so temperatures there are around 300 degrees below 0 Fahrenheit. This model of the terrain is made possible by Lunar Reconnaissance Orbiter, which has been mapping the surface of the moon from lunar orbit since 2009. LRO's maps will be incredibly important for exploring the moon and locating water and other resources there.
So as you can see, the sun and the moon and the Earth all interact like that, and the sunlight just basically doesn't get to the floor of those deep craters. And Shackleton crater was mentioned there. We'll talk about that in a little while. The Lunar Reconnaissance Orbiter, as it said, has been incredibly important in mapping the moon's surface and finding this water and giving us an idea of the best places to land. And here's a very short animation taken from images by the Lunar Reconnaissance Orbiter. It's sort of a flyover of the lunar South Pole, so you can see for yourself exactly what the terrain looks like. There's no sound on this video, by the way, because there's no sound in space. It's going to be very difficult terrain altogether to land on. It's not easy, which you will see as we approach the lunar South Pole. And I'll show you exactly where the South Pole is in a moment. But this is exceptionally rugged, dangerous terrain for any spacecraft to attempt to land in. Bless you. So finding a flat surface here and getting to the South Pole, getting into an orbit that passes over the South Pole, and then finding a suitably flat place to land is a difficult task, but not impossible. And there's obviously a lot of planning going into this already for Artemis 3, which, as I said, should happen around 2028, although with the continued SLS delays, who knows whether that goal will be met. Anyway, just thought I'd show you exactly what that terrain looks like at the South Pole. It's a beautiful place. It's got a rugged beauty all of its own, but very, very dangerous. And Lou will be telling you about the dangers in a little while. I want to talk about Shackleton crater and the actual landing sites, because Shackleton crater it's about 12 miles across. It's about 2.5 miles deep, and the lunar South Pole is actually on the rim of Shackleton crater. If you look to the left where it says SP, that is where the lunar South Pole actually is. Now, NASA have put forward a number of landing sites. At the bottom of the image, you can see Site 001, which is the first proposed landing site. It's on a flattish ridge, if you like, at the top there. But, of course, it's some distance from the crater. So if astronauts want to actually find out exactly where that ice is in the crater, they've got quite a trek to get up to it. So there is, on the rim, further towards the center of the image, you can see Site 004. That's another proposed landing site, which is actually on the rim of the crater itself. Obviously, getting too close to the edge is going to be inadvisable. But on the other hand, for looking for this ice, it makes much more sense to land that close to the edge of the crater. Now, there's been a bit of debate recently about whether the ice is actually there and what form. So one weird thing about Shackleton crater is that if you look at it in the infrared, the walls of the crater are actually brighter than the floor of the crater. And this has been taken, well, one possible reason is that because of moonquakes, the sort of the regolith, the surface coating, if you like, of the walls of the crater, the soil, if you like, has been shaken and exposing darker material underneath. And that could be a reason for it. But there's a lot of controversy about how much ice is actually on the floor of the crater. And I think the conclusion at the moment is that the ice isn't just laying on the surface, it may be beneath the surface. Alternatively, it may not be there at all. So the jury's pretty much out on that one at the moment. But I think most lunar scientists believe that the ice is actually there, but it may not be in the quantities that we think it is. However, of course, we won't know until we go there. So this is all quite interesting. And just one last thing before I hand you over to Lou. Just a very short video about Shackleton Crater itself. And this is what it looks like. It's got this sort of a bumpy floor, which is going to be perhaps for astronauts to navigate. This is all a visualization taken from LRO images. And, you know, as it said in the previous video, it is twice as deep as the Grand Canyon. So it's not going to be easy to live and work in those conditions. And to talk about those problems, I'm now going to hand you over to Lou, who's going to tell us all about them.
Wow, that's a lot to unwrap. Okay. You want to bring up my presentation? I don't have any cool animations and music like Andy does. On the other hand, there are no copyright issues with mine. Okay. So I was going to do kind of a comprehensive presentation today on all the ways that all the dangers and hazards of lunar habitation. But Artemis is pushed back pretty significantly. We have some time, so I thought we'd do this kind of one step at a time. So today we're going to talk about dangers of lunar exploration, radiation exposure, or how to die in space without really trying. It's really easy to do. When I give talks, I often, and there's time for Q&A, I often get asked, are you an astronaut? And
as if.
I say, hell no. There are too many people who still rely on me. Space travel is dangerous. And I'm going to show you one of the reasons it is. So let's get on with it. Okay, just kind of a little, just kind of a little summary. There are a whole variety of radiation threats when you move outside the Earth, when you move outside the Earth's protective shields. You can have particle radiation, such as galactic cosmic rays. We'll be talking about what those are, and solar particle events, right, from the solar wind. And not shown here, but you can also have electromagnetic radiation, like X-rays and gamma rays, which are normally filtered out by our atmosphere. And we've faced these problems before. We've sent people to the moon before for a period of days. We've had people in low Earth orbit, essentially outside our atmosphere, but within the magnetosphere for periods of months. But to live on the lunar surface, that's quite different. And there are a number of health threats that need to be accounted for. On the lunar surface, just as a kind of rule of thumb, you're closer to 400 times the radiation exposure as you are on the surface of the Earth. 66% of that are from GCRs, galactic cosmic rays. These are high energy, super high energy, super high velocity particles coming from outside the solar system, most likely from supernovas or other really energetic events. And that poses a cancer risk for astronauts. We already see this. You don't even have to go outside the Earth to see this happening. Airplane pilots have higher rates of skin cancer, right? And they're just flying up at 10 kilometers or 33,000 feet, or right around the tropopause. So, where the atmosphere is, most of the atmosphere is below you. So that's a problem. Even in our earthly daily lives. Now, if you just fly occasionally, you don't have to worry about that. But if you're a pilot and you fly 4 times a day, it's significant. So what are we talking about? Well, although we're generally not aware of it, we live inside a huge protective bubble that provides protection against the harsh environment of space. Both our atmosphere and the Earth's global magnetic field, called the magnetosphere, play crucial roles in supporting life on Earth. And without them, it's unclear if we would ever have formed life on Earth. Certainly not in any fashion that we are aware of today. The moon sits roughly 240,000 miles beyond the Earth, or actually these protective cocoons that make life on Earth possible. Earth's magnetosphere deflects the majority of charged particles, right, streaming out from the sun and from deep space, these galactic cosmic rays. But on the lunar surface, that shield simply does not exist. Without an atmosphere, there's no filtration of ultraviolet light or gamma radiation or X-ray radiation from the sun, no buffer against meteoroid impacts, by the way, no thermal insulation, and no insulation against these high-speed, highly energetic particles. So lunar habitats must replicate every single function of Earth's protective natural systems, or the astronauts will pay a price. This is one of the reasons, by the way, we're asked so often, why haven't we gone back to the moon in 50 years? And one of the reasons is that the goal of going back to the moon is to go back to stay. Of course, it won't be the same people forever and ever. They'll cycle, but much, much longer periods on the lunar surface. And solving the space radiation environment problem has not been easy and is still somewhat in development, as we will discuss. And that's one of many reasons that we have not gone back in 50 years. During a stay on the moon, astronauts will be exposed to elevated radiation levels due to the lack of the atmosphere and magnetic field. The absence of these shields allows cosmic rays of all energies to impinge on the lunar surface. Beside the continuous exposure to galactic cosmic rays, which increase the risk of cancer mortality, exposure through particles emitted in sudden, non-predictable solar particle events, SPEs, may occur from solar storms, coronal mass ejections, or solar flares. These SPEs show an enormous variability in particle flux and energy spectra that have the potential to expose space crews to life-threatening doses. Why would anyone want to go to the moon at this point? I don't know. On Earth, the contribution to the annual terrestrial dose of natural ionizing radiation by cosmic radiation is about 2.4, 2.5 millisieverts. Whereas the annual exposure caused by galactic cosmic rays on the lunar surface is roughly 380 millisieverts.
Ouch.
That's at solar minimum. Now, at solar maximum, it drops to 110 millisieverts. The reason that happens is that the solar wind during solar maximum is a much stronger force pushing back against the pressures of interstellar winds that provide galactic cosmic rays. So it's kind of 6 one way, half the other. If you're concerned with solar energetic particles, then you want to go at solar minimum. If you're concerned with galactic cosmic rays, you want to go at solar maximum. So it's a rather intractable problem. The analysis of worst case scenarios indicates that solar particle events might lead to exposures of about 1 sievert. So this would, we're talking millisieverts, so that's 1,000th of a sievert. So 1 sievert. The only efficient measure to reduce radiation exposure is the provision of radiation shelters. The hazards due to SPEs and GCRs have been identified as one of the major risks during human interplanetary missions. And these methods to reduce radiation exposure can be either active or passive. And we'll talk about that in a minute. Now, one interesting point, I said the moon is outside the Earth's protected magnetic field. Generally true, but not always. As the moon orbits the Earth, it moves into the Earth's geotail, the Earth's magnetotail, for something like 6 to 8 days every 29.5-day synodic orbital period. And this does provide some protection from the high energy solar wind particles, but the tail can be unstable. It kind of flaps around kind of based on solar wind flux. And so that unpredictability would expose astronauts to radiation.
Sorry, Lou, while you're talking about that, there's a question from Derek.
Yeah.
Derek says, landing in such a big hole, would that provide a little protection from radiation as it would pass over the rim?
It would provide some protection from solar energetic particles or solar particle events, possibly from galactic cosmic rays. One of the interesting kind of non-intuitive features of all of this is that as GCRs impact the surface, they actually generate and we'll talk about this in a minute, they generate a spray of secondary particles, which can also be ionizing radiation and bad for your DNA. And so as you penetrate the lunar surface, your radiation exposure for something like a meter actually increases because of these secondary particles. So I would say it's all in the geometry, but that's a very interesting point.
Great, thank you.
All right, so let's move on. Okay, so what do we see here? This is a graph of just to give you kind of a feel for the kind of dosages that you get from being in space. Now the moon is not on here. I couldn't really find one with the moon, but we can certainly translate. So you can see the annual radiation dose that you get at sea level. It's rather minimal. This is a log scale, of course, so even moving a little bit to the right produces a much larger dosage of radiation. Annual average radiation from all sources, maybe 3 or 4 millisieverts. An abdominal CT scan. I don't like these things. I think you get like the equivalent of hundreds of X-rays when the hospital tries to make its money back by using its CT scanner. So I'm not a doctor. I am not prescribing anything. The Department of Energy radiation worker might get a little over 10 millisieverts, and so on. So notice that the 6 months on the ISS, there you are essentially, for all practical purposes, outside the Earth's atmosphere. There's a little bit of atmosphere, but not worth mentioning. But you're not outside the magnetosphere. 180-day transit to Mars and 500 days on Mars, you are outside both Earth's atmosphere and magnetosphere, as you would be on the moon. Now, Mars has some atmosphere. It also has things called magcons, magnetic concentrations, which are places where the global magnetic field that Mars used to have has imprinted itself on the Martian surface. So potentially a Martian base in one of these magcon areas might provide a little bit of protection. But you kind of get the picture for a lunar base. It's many, many times the radiation level that you get from the surface of the Earth, and they wear badges. Radiation exposure is additive, right? So if you, it's like smoking versus alcohol. The effects of alcohol on the body are additive. If you stop drinking, it's whatever you've done, that's it. If you stop smoking, eventually the effects become less and less. So radiation is additive, and the damage that gets done is done, and it doesn't regress as you spend more time in lower dose environments. So let's see here. There we go. So this is obviously a little bit jerry-rigged slide. I found a good chart on the amount of galactic cosmic ray particle radiation through a series of years for about a decade. And then I'm under that, I'm putting a graph of the solar cycle, sunspot cycle, right? So the places where that peaks is solar maximum, and where there's a trough, that's solar minimum. So you can see quite clearly here that during solar maximum, there's a minimum in galactic cosmic rays. And during solar minimum, there's a maximum in galactic cosmic rays that have penetrated the heliopause and impinge on the Earth or the lunar surface. So that's just demonstrating that point that we already made. So on Earth, galactic cosmic rays are slowly varying. They're a highly energetic background source of energetic particles, and they're consistently bombarding the Earth or the Earth's atmosphere. They originate outside the solar system, and they are likely formed by explosive events such as supernovae, which we've already said. These particle events consist essentially of pretty much every element, ranging from hydrogen, which is most of it, hydrogen nuclei or protons. That's about 89% of galactic cosmic rays, to uranium and everything in between. And of course, as you go up the periodic chart, you get smaller and smaller percentages contributing to the galactic cosmic rays. These nuclei are fully ionized. They're just nuclei, no electrons. They've all been stripped away. And because of this, these particles interact with and are influenced by magnetic fields. Charged particles are influenced by magnetic fields. The strong magnetic fields of the sun modulate the galactic cosmic ray flux and its spectrum at Earth. Over a course of a solar cycle, the solar wind modulates that fraction, which we just saw, such that the majority cannot penetrate the Earth near solar maximum. Near solar minimum, in the absence of many CMEs, coronal mass ejections, and their corresponding magnetic fields, GCR particles have an easier access to the Earth and the moon. Just as the solar cycle follows a roughly 11-year cycle, so does the GCR, as we just saw. These charged particles are traveling at large fractions of the speed of light. They are relativistic speeds, and they have tremendous energies as a result. When these particles hit the atmosphere of the Earth, and we're talking about Earth now, we'll go to the moon in just a moment, large showers of secondary particles are created, with some even reaching the ground. These particles pose not much of a threat to humans and human systems on the ground, but they can be measured with sensitive instruments. The Earth's own magnetic field also works to protect Earth from these particles, largely deflecting them away, because remember, they're charged particles from the equatorial regions, but providing not very much protection near the poles, or maybe say above 55 degrees latitude. So that can result in increased radiation in some parts of the Earth, as well as for airline crews and passengers who are taking high latitude trips, just like the one I took to Iceland. Jesus, I better see my doctor. Okay. Additionally, these particles can easily pass through or stop in satellite systems, sometimes depositing enough energy to result in errors or damage in spacecraft electronics called SEP, single event upsets, or SEU, single event upsets. Isn't this exciting? We're learning all about how to die in space. Okay, here we go. I mean, what do you want? What do you want out of a YouTube show? We provide
Exactly.
So I said we get back to the moon. Galactic cosmic rays, again, primarily hydrogen protons, hydrogen nuclei or protons, and that's about 90%, alpha particles of 10%, and heavier nuclei, less than 9%. They strike the airless lunar surface continuously, interacting with the regolith to produce a secondary radiation field of neutrons and gamma rays. This interaction causes physical and chemical changes in the soil, including lattice damage, organic synthesis, and the generation of charged particles, creating a significant radiation hazard for human missions. When they strike the lunar soil, they collide with atomic nuclei, oxygen, silicon, iron, etc., causing nuclear fragmentation. These interactions produce a cascade of secondary radiation, including neutrons, gamma rays, electrons, positrons. Some of these secondary particles rebound or escape back into space, creating what's kind of effectively an upward directed albedo of radiation at the surface. Neutrons are particularly significant because they are highly penetrating and difficult to shield against. Due to the cascading effect, the total particle flux actually increases with depth in the lunar regolith before eventually decreasing. Most secondary particle fluxes peak around a half meter to a meter below the surface. So what that means is that you have to be careful when you're shielding. There's a bit of a shielding paradox. If you don't use the right amount if you're using lunar soil as your shield, it could be counterproductive and may actually increase exposure to astronauts as they are exposed to secondary neutrons produced within the shielding material itself. That just seems crazy. I don't know. Why are we going back to the moon? I'm now wondering. I don't get it.
Because it's there.
Some sick joke we're playing. Okay.
Because it's there.
It makes no
there.
sense. So the shielding against galactic cosmic rays and solar energetic particles on the lunar surface and in transit, right? Not just on the surface, but going from Earth to moon and back, requires a combination of hydrogen-rich materials. And this is the passive shielding that we mentioned a little bit earlier to block particle radiation, and for solar energetic protons, the creation of storm shelters. Because GCRs are high energy and produce secondary radiation when hitting materials, the best approach is to use materials with low atomic numbers, such as polyethylene, water, or the right depth, the correct depth of lunar regolith to minimize secondary particle production. This is not an easy, it's not as easy as putting tinfoil on your head. I know you're thinking, but it's more involved than that. It's much more involved than that. All right, so let's talk about shielding in transit, going to and from the moon. Transit vehicles are going to and do face continuous GCRs as well as unpredictable solar energetic particles from solar storms. Hydrogen-rich materials, such again polyethylene-based polymers, are the material of choice for shielding spacecraft in transit because they contain high hydrogen content, which is the most effective element at blocking space radiation without creating excessive secondary particles. For the unpredictable solar energetic protons from flares and CMEs, then the spacecraft have to include storm shelters, and we do this already. A heavily shielded area, for example, I think the example that I saw was 28 grams per cubic centimeter of aluminum or equivalent, where crews can take refuge during an event. Now, I heard a story quite some time ago. I don't know if this is true. I can't imagine. But in the early days of our space station, guys, you got to keep me honest here, guys, that astronauts would just pile one on top of the other because we have a lot of water in our bodies, right? So the astronaut on top would be the safest. And then, I don't know, is that true? That sounds crazy, right?
I've never heard that.
It does like my Saturday night.
It sounds like something Andy would include on Einstein of the Week.
No. On the contrary, Lou, it sounds like one of your fantasies.
Well, okay. There's that part too. Okay. Let's move on. And then you have to configure supplies, food, water, and waste. Supplies can be strategically arranged around crew quarters to act as additional shielding, utilizing mass that is already on board, so you don't have to add extra mass. There is advanced materials research. It's focused on hydrogenated boron nitride nanotubes. I don't know exactly what those are, but, and other boron-loaded materials that can reduce neutron doses by over 90%. So apparently this is, in fact, doable. Okay. Once you're on the lunar surface, the moon does provide some natural local resources that can be used for passive protection. For example, a regolith habitat, covering habitats with roughly a foot or more of lunar regolith can provide substantial shielding against GCRs and SPEs. Utilizing natural lunar lava tubes as a temporary or permanent habitat offers shielding equivalent to or better than being buried under regolith. And I think this is somewhat similar to the question we had earlier about being kind of deep in a lunar crater. Yeah. Spacesuits also must incorporate boron-containing materials or advanced composites to protect astronauts from solar flares, although they still today, they have limited protection against long-term galactic cosmic rays. So astronauts will have to minimize the amount of time they spend outside the habitat. Okay. Finally, we've been talking about passive shielding. There is also active shielding. This is being tested, but it is in fact a future concept because passive shielding heavy materials is inefficient to launch. It's heavy. Active shielding is being researched. Artificial magnetic or electrostatic fields could be deployed around a spacecraft or base to deflect charged particles, both SEPs and GCRs, before they interact with materials, similar to Earth's magnetosphere, right? You're creating kind of a local magnetosphere. This concept of shielding astronauts with magnetic or electric fields has been studied for over 40 years and has remained a pretty intractable engineering problem. However, more recently, superconducting magnet technology has made great strides, roughly in the past decade, coupling maturing technology with potential innovative magnetic configurations. So these could provide a lighter weight alternative to passive shielding, although they do require rather large power and cryogenic power supplies and cryogenic cooling. So I have taken my name off the astronaut list.
Oh,
I just, you know, there's more. I have a few things I want to do in life, but these are real problems that, I mean, okay, you know, spend a month on the moon. That's a lot longer than we have spent previously, right? What about Mars? I mean,
indeed.
Mars is a. I mean, I don't care how you cut it. It's a year and a half, 2 years, depending on your propulsion system. That's a real problem. The space radiation problem is the most challenging problem I think we have, bar none, in deep space travel. And we will talk about some of the other problems of lunar habitats and lunar exploration in the weeks to come. That's it.
Right. Thank
Yeah,
you. Very much.
yeah.
Thank you very much.
Yeah, thanks, Lou.
Wonderful. Well, as you can see, viewers, it's not going to be easy. And these are issues that are often not talked about in the public arena. A lot of people sort of concentrate on the whys and hows and wherefores of actually getting there and spacecraft and rockets and things. But these problems, as Lou beautifully pointed out, they're not intractable, but they're just very, very difficult. And it just makes you realize even more that humans really aren't cut out for going into space.
There's another part too with the radiation. It's not just the risk of cancer and dying. A friend of mine in graduate school went on to become an astronaut and flew on the International Space Station a few times for a couple weeks. Not one of these many months missions, but a couple weeks maybe or a month. And when he first joined the astronaut corps, he had perfect vision, like 10/20 or whatever, even better than perfect vision. And by the end of his tour, the astronaut, his vision was poor. And they determined it had been damaged by all the cosmic radiation that had just penetrated, into his eyes. So there's even other effects. And I know, Lou, I assume you're going to talk about the effects of gravity also, which is another thing that maybe not necessarily all permanent effects, but if you have effects that things that are doing things like that, well, I think the eye thing is a permanent effect, but not, let's say, not a fatal or terminal effect. But even beyond that, if you're debilitating astronauts, while they're in space, that does not bode well. I always imagined astronauts, and again, this is a gravity thing, but it's a similar kind of thing, going to Mars, landing on Mars, climbing down ladders and falling onto the surface, even though it's only 1/3 the gravity. When the astronauts come back from many months on the space station, they can't walk on the Earth. And I assume you're going to get into that. But the other thing is, in 1972, in August of 1972, between Apollos 16 and 17, there was a solar particle event that was massive. I mean, one of the biggest ones they'd ever seen. And they pretty much determined that if that had occurred during either Apollo 16 or 17, in other words, while astronauts were out in space or on the moon, it most likely would have killed them because it was such a high dosage of radiation. And basically, they missed it, right? And the instruments that the astronauts from the earlier Apollos set on the moon went nuts when that thing. And in fact, it damaged some of them when that occurred. So that's the kind of radiation dosage that, could just occur, right? This comes almost out of nowhere, these particle events. Anyway, I just to add that.
Well, there's also the story that, of course, the Apollo astronauts on the way to the moon kept complaining that they could see flashes in front of their eyes.
Yes.
Right.
Yeah.
Yep. Those were probably all doing a little bit of damage.
Yeah.
You know? Yep.
And in fact, they examined one of the helmets after the mission under an electron microscope, and you could see the holes that these particles had punched through the helmet.
Wow.
Which was quite amazing, really. Talking about Mars, viewers, if you'd like to know more about the hazards of getting to Mars, living on Mars, working on Mars, when we did Mars Month, I created a video about exactly that. So if you go to the Mars Month playlist on the channel, there's a video there all about the deadly hazards of living on Mars, well, getting to Mars and living on Mars, because, you know, the moon will be difficult. Mars will be incredibly difficult in terms of human health. It's lots of things we have not figured out yet. So when Elon Musk talks of going to Mars, well, it was meant to be this year that the first starships were setting off for Mars. He's talking out of his posterior, because there's no way that we are ready to mount a crew trip to Mars.
Here's a thought for you. I wonder if the any aliens out there have already realised how dangerous cosmic rays are. That's why they haven't come to visit us.
Well, yeah.
It's hard to argue with, Michael. I got nothing.
That's a new spin. I like that. Yeah.
And not only physically, but we will discuss the psychological problems of isolation, long-term isolation as well.
Yeah, absolutely. Well, thank you for that, Lou. We will carry on with this theme as we get closer towards the launch of Artemis 2. There's a lot to discuss about going to the moon, so we'll carry on with that. But right now, we're going to have a brief word from our sponsor. This video is sponsored by Picastro. It's like Instagram for space nerds. Big
Here's
thank
the coolest music. I love that.
So big thank you to Bruce McCandless for sponsoring Space Oddities. How's Picastro going, by the way, Tom? Are you getting a good community going there?
Yeah, really good. So we're getting close to about 3,000 registered users now. So
really,
not all of us are active. There's a lot of lurkers that are just kind of hanging back in the background, but every day there's more people joining, and the community is getting bigger. So it's fantastic to see. It's really nice to watch everybody engaging and communicating with each other as well. So it's going well.
Good. I'm glad to hear it. So if you would like to join a thriving astrophotography community, Picastro is the app to download, basically.
Yeah,
so,
it is.
Yeah,
it is.
So that'll cost you an extra tenner, by the way. So there we are.
And we have a question in the chat.
Oh, sorry. Let me shut up.
Yeah, Ian says, could we end up with a permanent presence on the moon of people who can never return? That's an interesting. I'm not sure on what basis that would be.
I don't think that would be such a concern for the moon. For Mars, possibly.
Yeah.
But the Earth is only 3 days away, so I'm sure. I don't think it'd be that much of a concern, Ian, about the moon. But as for Mars, that might because do you remember that years ago that scheme that somebody set up to get people to volunteer to go to 100 people to volunteer to go and live on Mars and not come back?
Yeah.
And it turned out to be a massive scam.
You're joking. Oh my god.
Yeah, no, it was. The guy
Wow.
who organised it was taking money, and nothing ever happened.
Oh
Yeah.
my goodness. Wow.
It was a complete scam.
Wow.
Well,
But
I remember,
lots
was it
of
Tito
volunteers.
who was going to send a husband and wife team to Mars? Not to land, but to kind of go around Mars and then come back to Earth over like 700 days. And I thought, well, only one of them will return alive. Dangerous mission.
That's a new TV show right there, Lou, I think.
And the other would wish they were dead.
Well, I don't know, Lou. They might come back with 3 or 4. You don't know.
Dave, you're always the romantic.
And of course, Elon Musk had the Dear Moon project, didn't he? For those who don't know, a few years ago, Elon Musk went into sort of, not partnership exactly, but there's a Japanese multi-billionaire who wanted to buy a trip around the moon on the SpaceX Starship for him and his mates. And it turned into an artist thing in the end. He was going to invite artists to go on the flight around the moon and represent it artistically in whatever medium they specialized in. But he cancelled the mission in the end because Starship was so far behind. So it never happened.
Crazy, absolutely crazy.
But there we are. All these mad schemes. But if we didn't have mad schemes, it would be a much poorer world, wouldn't it? So there we are. Right, we're going to move on now, and we're going to see how things are over at Roger HQ. And Roger's going to tell us all about the night sky, and we're going to have the gallery as well. So I'll hand things over to Roger.
Welcome to the coming of the end of February, and hopefully we might get some more clear skies like we have this evening. Typical. We're currently experiencing a first quarter up at the sky at the moment, heading towards another full moon coming up in another week. And we've still got the glorious Orion constellation, which is heading over towards the latter parts of the southwestern skies. But we have got Jupiter in all its glory still, and all's looking quite well. So what else have we got? So obviously we've got some of the planets, although there is in the news the planetary parade, although it will be rather difficult on the whole, because some of the planets will be too close to the sun to see and the others will be too faint to see. So we'll just have to end up watching either Mars, Venus, Jupiter and Saturn, and forget poor Mercury, Neptune and Uranus.
Might as well be a geologist.
Okay, so we're coming up to the first quarter phase tonight, and it's still looking rather spectacular out there as the show progresses. And we'll also be getting a few other things going on. We've got Venus coming more apparently into the sky as the week goes on as well. So have a look for that. But I will wait until after sunset before you get a chance to see it. But it will be becoming more and more higher in the sky as the weeks go on. So as I said, we've got Venus, Mercury, Saturn, Jupiter and Uranus. And I was made aware with one of my WhatsApp groups that Uranus is still visible, even though it is quite close to the moon up in the sky at the moment. But there is a good chance of it. And then we've also got Mercury's greatest elongation, so best on the 19th. So, that was a few days back, but never mind. But it is still getting quite. It's not too bad, and obviously with Venus getting higher as it gets onwards through the next week or so. Right, now this is an unusual looking sun over the last few days. It's completely spotless. So we do have some coronal activities on the go over on the western horizon there. We've got a little bit of a corona hole there, and we do have some interesting prominence action as well. But at the moment, there are no registered sunspots on the Earth-facing face of the sun at the moment. So it'll be interesting to see when we do get to see some spots over the next few days. But even when it has come round a bit more, there still won't be an awful lot to see at the moment. So bit of a disappointment there. So we have a little mini gallery, thanks to Tom and me. There's just some pictures of the moon that I took over a few nights ago, obviously not including tonight. So some interesting phases of the moon. The one over on the right was taken during the daytime, as you can see from the sky showing through quite nicely. Okay, and then we've got some of Tom's here, some details of the Rosette Nebula, and some interesting close-ups and details of that. So let me just move that on. So here's an overall view of the more central area of the Rosette Nebula.
Wow.
Wow. That's amazing.
Yeah, he's cutting down.
Yeah.
It's only about 20 hours, so he's cutting down really.
I'm slacking.
Looks like he took that up with
He's
some acrylics,
slacking.
I think. Wow.
Yeah, absolutely. Yeah.
Wonderful. Look at that. Well done, sir.
Yep.
That's fantastic.
And then we've got some closer details of the central region there, which he's highlighted. Ooh.
Wow.
Nice.
Wow.
Yeah.
Lovely.
So the circle,
There isn't
the
a
circle
physical.
bit there
There
is-
isn't. Yeah, I didn't know you could photograph circles in space.
the circle bit is a Herbig-Haro object. HHS.
Yeah.
Yes.
It
There we
looks so
go.
much better here than it did on Facebook.
Yeah, it's a shame really. Facebook just compresses it so much. So
Yeah.
Yeah.
Castro doesn't
Yeah,
know.
that's amazing.
Yeah.
So well done. And that's our little mini gallery.
Thank you very much indeed, Roger. Excellent. So there we are. That's the gallery and the night sky over with for another week. Don't forget, we would love you to send your astro images in so that we can feature them in the gallery. And of course, don't forget you get your own gallery on the Space Oddities website at https://spaceoddities.space. Very easy to remember. And if you'd like to contribute to the weekly gallery, we're looking for any sorts of astro images, and it doesn't have to be taken with expensive equipment. As we always say, a mobile phone is fine. Any image, it could be a skyscape, it could just be something you've gone out and taken with a mobile phone in your garden that you think is interesting or beautiful or dramatic or whatever. So any sort of astro image. Attach them to an email, one image per email, please, and then just mail them to gallery@spaceoddities.space. That's gallery@spaceoddities.space. And thank you so much for your support. And talking of support, many, many thanks to Deep Burrito for your exceptional generosity, sir. We're very, very grateful. And that'll, all the money we receive goes towards keeping us going. So Deep Burrito from the heart of my bottom, thank you very much indeed. And
There's not any way to treat it.
yes, but anyway, thank you for your exceptional generosity. We also need to say thank you to Gerard as well for your donation. Thank you very much, Gerard. I know you're not watching this live tonight, but I did want to say a big thank you for your continued generosity. Much appreciated. As we did, we appreciate everybody who buys us coffees or donates to the channel. So it just goes to prolong Space Oddities, and we couldn't do it without you. So thank you very much indeed. Okay, where we go next? So next we're going to talk. We're going to go over to Dave, and I think it's your regular weekly spot, Dave. The week in. So we'll pass things over to you.
Okay. Yep. Let me get my screen up there, and you should be seeing this in just a moment.
Just a wee second.
There we go.
A wee
Okay.
second.
So yeah. So okay, this week, solar system exploration. We've got lots of interesting stuff. I always try to find kind of a little bit oddball things as well as things that are really critical to our exploration of the solar system and the universe. But to start off with, February 22nd, 1961. So we'll go back quite a ways. This was the first French life science launch. They took a rat named Hector, as you can see in the picture there. He was loaded into a Veronique rocket, and in the bottom picture you can see the little chamber. He's inside that little chamber. They pop him into the nose cone of the Veronique rocket. It launched up from Algeria. This was back when Algeria was owned by the French, and launched to 152 kilometers. Recovered him successfully, and I guess he lived a good long rat life after that. But you can see him in his little they put a little suit on him, a little basically a series of electrodes and whoops, what happened? What is happening here? I'm sorry about that. Anyway, they monitored his heart rate and his breathing and all sorts of biological whatever was going on, they measured that during his flight and to get an idea, and it actually became a bit of a thing. You can see they actually made a stamp out of it with that picture. It's kind of hard to resist that picture. And then the cat is actually a Félicité, which was launched later on. Was actually launched also on a rocket successfully again. Was recovered successfully. And anyway, so there you go. That was I think
just two things there, Dave.
Yes.
I'm glad you said that Félicité was launched on a later mission, because I would question the wisdom of putting a rat and a cat together in the same spacecraft. And also, although it says Hector was successfully recovered, it didn't say whether he was recovered alive or dead.
No, alive. No. I said he went on to live a good long rat life, whatever that means.
Fantastic.
Yeah. So right. It wasn't a Leica kind of thing.
No, Monsieur la raton, c'est pouf.
No, the only funny thing about it that I saw was there was a rumor, I guess, or whatever. It was said that the original Hector chewed through the wires on his little vest there, and it was replaced at the last minute with another rat. But I don't know if it matters so much that it was named Hector, or in other words, I don't know what that means. It may be that the rat in the picture sitting there with the cat was not the rat that was launched into space, but I'm going to assume it was, and if it wasn't, I'm going to assume we wouldn't be able to tell the difference in any case.
1961 though, gosh, amazing.
Yeah. So France was doing this kind of stuff, and anyway, that's pretty cool. Okay, so what have we got? All right, February 22nd. Okay, the Luna 20, which landed on the moon, and I think I may have mentioned it last week because it was earlier in February when it had launched. It did land. It did collect lunar samples. If you see on the top picture there, the little sample container, the little round thing on the top is basically a sample container, and it opened up, and then that little scoop, sort of the thing sticking out with the can on the end, was scooped up a sample, dumped it into the sample container, returned it back to Earth. It landed in Kazakhstan. You can see it's February, right? And we're in Kazakhstan in February. Of course, it landed in the snow. It actually landed on, as luck would have it, on a small island in the middle of a river, and they managed to recover it without a problem. But I don't know what would have happened if it had landed in the river. I don't know if they had a plan to recover something. Again, the river might have been just frozen, so maybe it wouldn't have mattered.
Yeah.
It would have just landed on the ice. That I don't know, but it did land on this small island.
Kazakhstan in February, that seems highly likely it would have been frozen.
That the river was frozen solid.
Yeah.
Yeah, I have to agree that that sounds most likely. But in any case, this was only the second sample ever robotically returned. It was oh boy, you know what? I don't remember. I should have put this down. I think it was at roughly 300 something grams. So not an insignificant sample brought back. And they did share this sample with the United States, and it did, more importantly than the fact, I mean, it wasn't obviously as big as the Apollo samples brought back, but it was another spot on the moon that they got the samples from. In other words, so it's just one more place that they got samples from, and even a few grams of samples, you can analyze that. You can learn a heck of a lot about a place. So it was interesting. It was quite a step forward in any case. Okay, February 22nd, 2019. So okay, 7 years ago. Hayabusa 2, and you may have seen this because they did stream this live. JAXA. They landed on Ryugu, touchdown. It made two sampling runs. This was the first one. It pulled back 3.2 grams on this first touchdown, and then the second one it pulled back another to give a total of 5.4 grams. And the picture at the top right there is actually just taken from the live stream. So this is just after it had hit down on the surface. It shot a little projectile into the surface and just knocked up a bunch of stuff, and then it had a big funnel kind of collector in there, and the samples just fell into it. If you remember seeing it, you saw when it pulled away from the surface, there was all sorts of dust, and because of the microgravity, obviously, the stuff just looks like it's kind of floating in the water or something, and it's obviously just floating in space because this Ryugu is not pulling it back down very fast. So the stuff kind of went all over the place. And I really do like the picture over on the left, the bottom left there, because you can actually see the shadow of the spacecraft in the very lower center of the picture. And you could see that on the live stream as it was going up. You could see the shadow of the spacecraft there, and I just thought that was kind of cool. Anyway, okay, so let's see, where do we got here? February 23rd. Okay, so if you remember some time ago, not too many weeks ago, we talked about the first rocket mail ever launched in Austria. Well, they tried to do the same thing a little bit later in the U.S. It went about. Apparently, it went up into the air. Well, first off, you can see the rocket, the little airplane kind of device there in the at the right. It was actually they actually wrote an article about it in Popular Mechanics magazine, and there's a lot more detail about it. It's easy enough to look up. Greenwood Lake, New York. If you're interested, they have the PDF of the article you can get online. But they launched with some official U.S. mail from the New York side of this Greenwood Lake, and it made it over to the New Jersey side. Apparently, after zipping around and flying in over the crowd, which was about 500 people, I guess, came to watch this thing, flew over the crowd and made everyone a little bit nervous at first, but did did actually make it over to the New Jersey side of the lake, some maybe 100, 150 yards away. Again, this was all done in the snow as well, but they did that. Anyway, it was the first rocket mail. An example, really, of why rocket mail never kind of caught on as a really.
I just realised if you look at the middle image where it says rocket airplane.
Yes.
Mr. W. Lay, that's Willie Lay, the famous rocket pioneer.
Yes, I saw that, and I didn't see anything more about Willie Lay's involvement in this, so I don't know if I didn't think that he was actually involved in the thing or involved about writing about it. I wasn't quite sure. Yeah, it's interesting you noticed that. I noticed that too, and I thought, yeah, of course he's kind of right, one of the godfathers, I think, of
Of rocketry, yeah.
Yeah, rocketry, yeah, and especially popularizing rocketry, I think, because he wrote so many books, and I can even remember when I was a kid seeing some of these books. So yeah. Anyway, this was again interesting. February 23rd. Okay, so getting out of the solar system a little bit, the supernova 1987A, the first. Well, the brightest naked eye supernova, brightest supernova observed since 1604, and the first one that was actually observable by the naked eye since 1885. It was in the southern sky, so for most of us, that wasn't something that we can remember. But first seen at Las Campanas, and I think it got up to magnitude 5. So it wasn't one of these supernova that you read about where you can see it during the daytime and that kind of thing, but also showing you, I guess, basically, I mean, this would be a bucket list thing, really, to see a supernova, a really bright one, but you can see how unusual. That's 100 years since the last observable naked eye observable supernova. But it was a kind of a big deal at the time, and I remember a little bit about this when it happened. So, okay, all right. So, well, we're today, February 24th, from White Sands. What they did was, of course, at White Sands was where they brought, and I think I even mentioned this last week. It was one of the things they brought all the pieces of the V2s that they brought back from Germany. And they brought the rocket scientists, and they brought them all to White Sands, and they reconstructed these V2 rockets. Well, after they'd done a whole bunch of test flights, they took one of these V2 rockets, and in the compartment where they normally would put the bombs, they attached a what's called a whack corporal, which was a sounding rocket. And they hooked it up so that it would, when the V2 reached its maximum height, maximum altitude, it would launch the whack corporal, and it worked. And the whack corporal actually went up to a height of 393 kilometers, 244 miles.
Wow.
By far the highest launch up to that time. The first spacecraft over 200 miles. Yeah, depending on where you think space begins, this was considered to possibly be the first thing that reached space. There were other things that had reached what other people consider space above the von Karman line and that sort of thing. But of course, space does not have a line, and so. But in any case, this was by far the highest launch up to and this is 1949. So we're still a decade away, more or less, from almost a decade away from getting stuff into space regularly. Let's put it that way. So this was a big deal. The image at the left is actually this launch. The other two images are just showing you what the rocket looked like, but it's a couple different of these bumper whack launches that are showing there. But this was the one that really that achieved the greatest altitude by far. Okay, so just so we don't want to think that we're all one-dimensional astronomers and have no culture. February 27th, 1919 was the first public performance of Gustav Holst's The Planets at the Royal. Yep. So that's kind of cool. At the Royal Philharmonic in London. It's interesting because at the first public performance, they actually didn't play all of the planets. The conductor, Adrian Bolt, decided that basically the entire solar system would be just too much for a normal audience. So they actually left out Venus and Saturn.
Oh, how
and they only played 5.
Venus is wonderful.
I know, and Saturn too. I mean,
both of them, yeah.
So they actually played it, and they played it out of order. So they played Mars, Mercury, Saturn, Uranus, and Jupiter.
I noticed they left out the women. Okay.
Maybe.
Yeah.
I don't know. I don't know. But in any case,
And Pluto.
And Pluto gets left out again. No, but it's it's interesting. Holst really always wanted this thing to be played fully and in the right order. But he and Bolt were good friends apparently, and Bolt just decided this, and Holst went along with it. But the very first public performance, at least, was just 107 years ago. Yeah. Anyway, so again, another little bit offbeat, and hardly critical to our planetary exploration, but.
And here's an interesting thing, Dave. That was the first LP I ever owned.
Is that right?
Yeah, I had a recording of the planets. I can't remember who the conductor was or what the orchestra was, but my parents bought it for me when I think I was about 6 or 7. And,
so it was already clear that you were going to waste your life with this kind of stuff. Is that?
Oh, absolutely. And I loved every minute of it, and I still do.
Good. It's wonderful. That's great. My first wife would always play this. We had astronomy night at UCLA. We'd open up the observatory there and look at various planets. And she and I helped her. We would run that thing every week. And in the background, she would play the planets. Yeah, it was pretty fun. Okay. And then another one to maybe make you feel old. I don't know. The announcement of the discovery of the first exoplanets ever. They were around a pulsar, which is what made it actually easy to discover them, because they were affecting the pulsar. Pulsar has such a regular rate. I mean, that's the point of pulsars, right? They have such a regular rate of they're pulsing because they're spinning, and the spin, of course, is affected by planets around them, and they managed to discover that there were 3 planets around this pulsar. Not too long after that, they really started discovering planets around normal stars, the kind of things that we really think of exoplanets that, and then start talking about habitability and stuff. But these were the first planets ever found outside of our solar system using Arecibo. And that was 1994. And I remember that really well.
Yeah, me too.
And
I remember the skepticism.
That's true. There was that too. That's right. And it is kind of funny, isn't it, to think that the idea of a planet's outside our solar system somehow, you really needed this really had to be.
And then on top of that, orbiting a pulsar. Are you crazy? Planets can't orbit pulsars.
Well, and of course that's still, and as far as I know, and you more astronomy type folks might know better than I do. I still think that that's kind of a problem, right? I mean, how the heck did these things ever survive? And I guess maybe one of the ideas is that they came in later. In other words, they were captured or something. I don't know. Anyway, not time to get into that now. But
no, there is an answer, Dave. But how much time have you got? Basically, it's a long.
There is an answer. All right. Well, anyway, that'll be interesting.
Basically, it is possible.
Yes. Yeah. Okay. And February 28th, 1959, Discoverer 1 was launched, or Thoragina. This was the first satellite ever launched into polar orbit, oddly enough, in 1959, and it was the first launch from Vandenberg, which of course Vandenberg is used for polar launches now, and I guess this is the first. These discoverers were really interesting, and I'll get to the stuff at the bottom there in a second here. But they carried these cameras and film, real, photographic film. They took pictures. Of course, they launched them over the Soviet Union mostly, and took pictures from orbit, really high resolution pictures, and then, when they were done, after they'd made a bunch of orbits and the Earth would turn below them so they could cover the entire Soviet Union or whatever they were looking at, they would drop the film canisters. They would eject the film canisters and they would deorbit, and they had a parachute, and they'd come down to Earth, and then they'd recover them. The first, I think, 12 of these things didn't work for one reason or another, and finally, number 13. Everything went successfully. They recovered the film canister, and after that, they were using these regularly, and then they became the Corona program, which is the next step in their photographic satellite. But this did turn into a movie because they made a movie based on the idea that the satellite had the absolute state-of-the-art camera and photography in it, but it malfunctioned in such a way that it took pictures of everything. So it had pictures of the United States as well, and so that the pictures from this camera would be a vital treasure trove for either the Soviet Union or the United States, whoever could get hold of them. And because it was not working correctly, it actually dropped it accidentally into the Arctic. And so there was a race to the Arctic, to the North Pole rather, to recover this film canister between the Soviet Union and the United States. And there's two submarines going underneath the ice and racing to recover this. And they made a whole movie about it called Ice Station Zebra, which is kind of a fun watch.
Yeah, very good film. It was based. It was based on the book of the same name by Alistair MacLean.
Alistair MacLean, right.
Who wrote many fantastic thrillers.
I thought it was interesting that they really did, base this on an actual program. And you know, a reasonable idea that the thing malfunctioned and just took pictures of everything, and suddenly it was valuable to everybody to try to recover this. Anyway, so there's another little bit of offbeat history, but this is back from 1959, and I believe that is it. Yes, that's it. That's all I've got.
Just
all right. Well, thanks.
Thanks, Dave. Just one final thing about this. The Agena, of course, went on to be to be used in docking practice, of course, during the Gemini.
Right. And one of them failed, right? And it was the alligator, they called it, or something, because
it
didn't open up correctly and they couldn't dock with it. Anyway, yeah.
So there we are. Dave, thank you so much for another really interesting week in. There's always lots going on, isn't there? No matter what the week. Always an anniversary of something. Just makes you realize how far we've come. We've gone from sending a French rat into space in 1961, and then only 8 years later putting people on the moon.
Right.
So amazing stuff. Anyway, I hope you enjoyed that, viewers. We're going to move on now, and we're going to go over to our regular weekly feature. This week, what am I trying to say? Thank you, Roger. We'll go over to Constellation of the Week. And what is it this week, Roger? Roger?
Right.
Earth calling Roger.
Sorry, I was on mute. Right, we're off to see Hercules. It's one of the larger ones, Michael.
Yes, I do. I do know Hercules.
Yes.
Finally, a decent constellation.
None of these zodiacal ones. So, we've got Hercules, which is well known from various legends, especially the Romans as well, famed for his 12 labors. There we go. And it was one of the 48 constellations catalogued by Ptolemy in the 2nd century. And if you want to look at and have a look for it, it's visible from late spring to early autumn. So it is quite a good one to catch. So it's the 5th largest constellation, covering 1,225 degrees, and is traditionally depicted with one arm raised holding a club. And the star Alpha Hercules is Razel Gethy and marks the head of the Kneeler. So there we go. So using various stars, we can picture it between Vega and Arcturus, roughly about a third of the way between the two. So most people know where it is. It's quite a distinctive constellation. So the club part of the constellation, we've got Beta Hercules, which is Corniferous, Alpha Hercules, which is Razel Gethy, and we've also got Zeta Hercules. So Alpha Hercules is a triple star system. Wow. With a red supergiant at 360 light years away. Beta Hercules, which is magnitude 2.8, is 148 light years away, and Zeta Hercules is a mere 35 light years away. There we go. But most we'll come on to that in a minute with the most famous part of Hercules. So we've also got double and multiple stars of Delta Hercules, which is a blue-white companion. We've also got Gamma Hercules, which has got a faint secondary star with a white giant. And then we've got orange and blue hues of Razzlegethi as a double star as well. So that's quite a nice one to see. And of course, everyone knows M13, which has got roughly 300,000 stars packed together, and it's 25,000 light years away. So most people will be able to get an idea of what it is from even a pair of binoculars to see a little fuzzy patch there. But obviously, the bigger the telescope, the better resolution that you can get to see those stars all clumped together. But also, as well as M13, we've also got NGC 6210, also known as the Turtle Nebula. This image was done with the Hubble telescope, so that should be a bit of a challenge, but I'm sure it could be achieved with some larger apertures. We've also got a globular cluster M92, which is magnitude 6.4 and 26,000 light years away. And we've also got MGC 6299. So we've also got some interesting objects as well, not to miss from M13. So at the moment, it's with the Earth's precession, it has now upside down.
Oh,
From its it has rotated round to its on it. So it would be the right way up if you were in the southern hemisphere, if you could see it from there. So that would work for them. But interesting to see that the constellation orientation has changed due to the precession of the Earth. So an interesting fact there. Okay, and that's a little brief. Some brief little tidbits of Hercules that some of you might not have known.
thank you very much indeed. And Hercules, of course, legendary strongman. Well, I mean, he wasn't that good, was he? He's standing on his head. I mean, that's. I can't imagine him winning many victories like that. Anyway, thank you very much, Roger, for Constellation of the Week. And lastly, this evening, we're going to go over to Dave, who's going to tell you all about our Messier knockout.
Okay. Yep. I first start out with, I guess I would say the rules. All right. Let me see. First off, if I can get them up there, which I seem to be having trouble. All right. Okay. Now let me see if I can get it to do this window. Now, all right, there we go. So I hope this comes up momentarily. There we go. All right. So I kind of threw this together. It could be a little more coherent. I could spend a little more time on getting this organized. But okay. I spent a lot of time getting it organized. I don't know if I spent a lot of time explaining it, but here we go. What I'm going to do is present two pairs of Messier objects each week. I'll have a picture of each one, but that I've just picked out on my own. And feel free to look up other pictures of the object or anything else you want if you're interested in the history of the object or whatever. I kind of feel like we should be judging these based on what someone could see from the Earth. And so one for example, if you're looking at the Eagle Nebula, don't look at the Hubble images of the Pillars of Creation saying, "Oh, the Eagle Nebula is so wonderful. Look at these Pillars of Creation," and vote for it that way. But you can vote on it however you want. I'm just going to give little guidelines here, and please just do whatever you want. You can send the votes to Dave at spaceoddities.space. This will all be posted as well, so you don't have to take notes now. The vote can easily be in the form when I put up a couple pairs, you just pick one from each pair and just put it in the text, M12, M34, whatever you want. please put Messier in the subject line, obviously to be able to separate that from all my fan mail. Have your vote in. Yeah, I know. Okay, have your vote in by. Well, I have 8 a.m. Pacific time, so 16 UT on Monday, and then I'll have a little time to put together, an announcement for the winners, which I'll do on the Tuesday meeting of Space Oddities. I'm going to put in 2 pairs of images for the first 2 rounds, because otherwise the first round alone would take 32 weeks, and I don't know if we want to drag that out this long. And then that'll short it down a little bit. But basically, okay, the main thing is everything's up to you. You could vote an image because you like it, it's prettier, it means something to you, you like the name of it, it was the first image you ever saw, it was your Aunt Mabel's favorite Messier object, whatever. Basically, it's completely subjective, it's completely up to you what you're voting on. And at the end, we'll have a knockout bracket, and at the end we will have a winner. And that's going to be, 37 weeks from now? I think I figured this out. Now I'd have to figure it out again. All right, so let me get back to sharing my window. The best way to do this is probably like this. Okay. Share this window. So, all right, so here is our starting bracket. I have 4 of these, obviously, but they're not all going to fit. So here's our first bracket, just for your information. I will post this up as well. So again, you don't need to take notes. But this is our bracket. I've tried to take images of different objects, at least for the first round. After that, all bets are off, because they'll be matched up however they match up. But I tried to keep nebula, galaxies, things a little bit separate, so you're not judging 2 galaxies against each other early on. At least they're different, and I've tried to they're not seeded in any way, but I have tried to take some of the more spectacular objects, let's say, and so they're not meeting up in the very first round. But again, that's just my judgment, and you may you'll have to see what you think. Okay, and so let's go to the first round here, and maybe I should do this as a full screen thing. So hold on a second. Let me. It's a little hard to do these in multiple, so let me put that in full screen mode and see how that helps. So our first 2 Messier objects. And share the screen. Okay. Our M77 and M24. They're coming up momentarily here. There we go. Okay. So M77, Cetus A, it's a barred spiral in Cetus, and M24 is the Sagittarius star cloud, which oddly enough is a star cloud in Sagittarius. And I just put the distance they are away and sort of how big they are, just to give you a general idea of what you're looking at and how far away it is. But again, these will be posted. Take a look at them here. Get an idea. And if any time in the next week you can send me your vote, that would be cool. And I will compile them. And hopefully this is fun and there's enough interest. And let me give you the other pair. The Dumbbell Nebula M27 in Vulpecula, which is the fox, I guess. And M86, which is a lenticular galaxy in Virgo. So pick your favorite of those 2, and then the 2 winners will move on to the next round. And next week I will have another 4 from the first round sort of bracket there. And again, all this will be posted so you can take a look at it. Go and find your own images of these things. These are not the definitive images. These are just some images that I picked to illustrate these. So. And I guess, that's what I've got. Also, if you have any questions, feel free to send them to Dave at Space Oddities, and I'll try to, be able to answer your questions about it.
Okay, thank you very much.
Thanks.
So just to clarify, viewers, what we would like you to do, if everybody watching could take part in this, it would be great, because if we only get 2 votes, then we'll have to rethink the whole thing. We'd like everybody to participate. So the images and the rules will be posted tomorrow on the Space Oddities website, that being https://spaceoddities.space. Go along there, have a look at them, and then send Dave an email choosing your favorite out of the two pairs. And there we are. That'll be up sometime tomorrow. So and if you get, as Dave said, you get your votes in by next Monday, that would be terrific. It would be really good if we had a nice response to this, because it's, it's a bit of fun just to involve everybody. And it'd be interesting to see which is crowned the top dog messier. Okay, thanks for that, Dave. We look forward to receiving your votes, viewers, and thank you very much for your support. So we'll draw things to a close for this evening. That's about all from us today. And thank you for watching. Thank you, Deep Burrito again. Thank you, Gerard, and other contributions. Much appreciated. We will return next week. Now, because we've talked about Artemis, and we're going to carry on talking about Artemis, whether you like it or not. Of course, Artemis 2 is the dress rehearsal for Artemis 3. And, as we've said, it's a circumlunar mission to put 4 astronauts on a trajectory around the moon and then back to the Earth. As a dress rehearsal for Artemis 3, which hopefully is coming up in 2028, when humans will actually walk on the moon for the first time since 1972. With this in mind, there's an historical precedent for this, of course, because over Christmas 1968, Apollo 8 did exactly the same thing, sent 3 astronauts around the moon to test everything before they were confident that they could land Apollo 11 on the moon safely and bring the astronauts home again. So commensurately, Apollo 8 was also a dress rehearsal for Apollo 11. So what we thought we'd do next week is take a look back at Apollo 8, do a bit of a retrospective mission, and talk about what was achieved during Apollo 8 with view to hopefully seeing the same sorts of things achieved with Artemis 2. So next week we'll be talking about the Christmas 1968 mission of Apollo 8, among other things. Until then, it's good night from us all. Thank you, Roger. Thank you, Dave. Thank you, Lou. Thank you, Michael. Tom had to leave us early to go and pick his daughter up from the station. So he's not with us at the moment, but thanks to Tom as well. And have a fantastic week, everybody. Thank you so much for your support. And thank you so much for watching, obviously. And we will see you next week. Have a great week. And from all of us at Space Oddities, we will bid you